So the standard figure, right? Till now, if you have seen earlier videos in the geometry, we have talked about shapes, 2D shapes, rectangles, parallelograms, quadrilateral, triangles, etc. Now this is a 3D geometry, that is, we are getting to the third dimension. So the basic example would be a cuboid, which is basically built on a rectangular, 2D figure, which is basically extended into the third dimension, which will give me into a 3D third dimension. We'll get a cuboid. What do I mean by that? Let's say I have A, B, C, D. This might look like a bit of a parallelogram. That's because we're trying to see a 3D diagram in a 2D, a screen. That's why you will get a feel like that. But understand, actually ABCD is a rectangle. Like if I see it from the top, I would see ABCD like this. That is basically, these are all 90 degrees, right? So ABCD is a rectangle. Now let's say, as I said, this is length and this is breadth. So this is length and this is breadth. If I extend this into the third dimension, right, across this entire length, right, let's say this is height h, then I get a cuboid like this. A room is a perfect example for a cuboid. If you are in a room, just look at the entire room, we would be ideally seeing a cuboid. Like the tiles on which you're standing or sitting is basically like the floor which I'm talking about here. And when you raise your height and see at the ceiling, you will get a ceiling, right? And then the walls which you see to the right and left would be these walls, right? The four walls, the first at the front and the back and the right and the left, right? Which I have sort of shown it here. If you see, we have totally 6 rectangles for the cuboid, right? This is the length and breadth. This is the floor, right? This is one of the rectangle, right? And the ceiling would also have the same length and the breadth, because it's the same rectangle we see at the top at the bottom, right? This is the same rectangle which is shown at the top and the bottom. This is my second rectangle. Now let's look at the third and fourth rectangle, that is in the yellow color, right? A, B, Q, P. This is my third. What would be this AB? That's L, and QB would be H, right? Because QB is H, that's the height through which the 2D figure rectangle has been pulled into the third dimension to get a cuboid. So that's H. So area would be L into H. But anyways, so A, B, Q, P is the third rectangle, and then the one which you see at the back is D, C, R, S is the fourth rectangle, which would also have the same L and L and H and H. So L into H would be the area for that. And then we have two more on the right and the left, that is BC, RQ. This is my fifth rectangle. What would be this? QB is H and BC is B, right? H and B, similarly B, B, H and H. So that's H, H, B. That's how it is, right? So this is my sixth rectangle. So we call them actually 6 faces. A cuboid has 6 faces, like first, second, the floor and seal, third and fourth, the front and the back, and the right and the left are 5 and 6, right? So that's how we have 6 faces, and each face has its own area. If you see, what is the area of the floor? L into B, and the ceiling also L into B. The one at the front is L into H, and the back also is L into H, and this would be H into B, and this would also be H into B. So altogether we have 6 faces with 6 different, actually 3 different areas, but we have 6 faces. So that's basically each area as LB is seen in 2 rectangles, LH is seen in 2 rectangles, and BH is seen in another 2 rectangles, right? Keeping this in the mind, let's get to the standard things that are required to solve the questions based on this. First, the volume. Like how we talked about area for 2D shapes, the volume is the one which we'll generally talk about. That is basically length into breadth into height, right? So for a cuboid of dimensions L, B and H, it will be L into B into H. What is the lateral surface area? Surface area. For some shapes which have curved figures, like we'll also call them curved surface area, it's fundamentally the same. The one which, the areas of all the faces are the surfaces, excluding the top and the bottom, that is the floor and ceiling, right? What is that? So basically, as I said, cuboid has 6 faces. The area around it, right? If I see the room I am in, if you see the room you are in, you should be seeing 4 faces. One at the front of you, the back is another, and then to the left and the right. The ceiling and the floor would be the 5th and 6th, which we are not counting in the lateral surface area, right? So they basically have to count 4 faces in the case of cuboid, and some of them would be 3rd and 4th, 5th and 6th, right? That's basically LH plus LH plus BH plus BH. So H is common. If I take it, I'll get 2L plus 2B. So if I take 2 also common, it will be 2H into L plus B. That's basically the formula. 2 into height into L plus B. The total surface area is always the lateral surface area of the curved surface area plus area of the bases. I need to add the floor and the ceiling. So basically for the cuboid, I have to add all the 6 faces. Right? That's basically L into B plus L into B is the floor and ceiling plus L into H plus L into H plus B into H plus B into H. So that will turn out to be 2 times LB plus BH plus HL. Right? That's the formula for the total surface area. We have not written it here. But you see, if I just add to this, this is the lateral surface area, the bases, the floor and the ceiling. That's how you derive the formula for the total surface area. Always keep in mind, total surface area is the lateral surface area or the curved surface area depending on the shape we are talking about, plus area of the bases. Then there's something called 3D diagonal. Might not always see it being used as a term, but rather understand the application. What do I mean by 3D diagonal? So joining A to R, right? That is a line like this. R, S and B. Right? R, I join D and then Q. Right? All of these are the 3D diagonals. So the length of it is L square root of L square plus B square plus H square. So the questions that you would rather see where you have to apply this is the longest line, I can make in a cuboid by joining any 2 vertices. Like if I join AD, I get a side. AC, AB, I'll get a side. AC if I join, that's a 2D diagonal. Basically it's a diagonal in the rectangle, like this diagonal, right? Square root of L square plus B square. So if I join any 2 points in the entire cuboid, right, not just the vertices actually, any 2 points, even if I join 2 points like this, which are on the cuboid, I would not get as long as what a 3 diagonal would be. So 3 diagonal is the longest one which, could be made by joining any 2 points on the cuboid. So that's one way of asking the question. Or sometimes they say there's a negligible rod. When I say negligible rod, as in the rod with almost 0 thickness, it's like basically a line sort of it. If I have to fit it inside a cuboid room, what would be the length of the maximum length of the rod that I can fit into a cuboid? So that's again basically asking you to calculate 3 diagonal. You just need to use this square root of L square plus B square plus H square and you'll get the answer. Right? Edges of a rectangular box are in the ratio 1:2:3. I'm talking about length is to breadth is to height of a cuboid is 1:2:3. And its surface area is 88. Whenever they just say surface area, take it as the total surface area. Unless they specifically call it a curved surface area, lateral surface area, they are referring to the total surface area, which simply surface area is 88. What is the volume of the box? So whenever I see ratios, I immediately assume them to be L is 1K, B is 2K and H is 3K. Because they are in the ratio, I am taking a new variable called K. Right? What is the total surface area formula? 2 into LB plus BH plus HL. That is 2 into L is K, B is 2K, so it's 2K square. BH is 2K into 3K is 6K square. HL is 3K into K is 3K square. So that is 2 plus 6, 8 plus 3, 11K square into 2 is 22K square. So total surface area is 22K square. Right, now I know that, and what is a total surface area given as 88. So 22 1s are 22 4s are, so K square is 4, K is 2. Once I know K is 2, I know L is K, that's 2, B is 2K, that's 4, and C is 3K, that's 6. So what is the volume? L into B into H is the volume of the room or the cuboid or box. So 2 into 4 into 6, that is 48 centimeter cube. That's the answer for this. Right? Simply they have given us a clue connecting LBH. They've given a value for total surface area, substitute to get the LBH individually and then find the volume. All we did is apply this formula, total surface area, and then apply the volume formula, right? Nothing more than that.